All right, guys, second part of chapter 11. So we just finished explaining how dams work. We're going to discard. We're going to go back, and we're on page 3. Okay. A reservoir is an artificial lake formed behind a dam. So that's before it, right? That's that lake that was formed because the water is being blocked. Okay. An example of a water diversion project would be the Colorado River and the Southwest, where they had major relocation of the river by diverting it into canals. They carry water into different areas that didn't have water before, allowing those areas to become habitable. Pros, you've got drinking water, you've got recreation, and you've got hydroelectric power. Cons, you disrupted the environment. Displacing people, possible dam failure, that's definitely a possibility. So, what are some things we can do to conserve our water? Drip irrigation. This stuff is so cool. So, I'm pretty sure I'm going to show you. Well, here, I'll do it now. I'm going to block something for a second. Okay. Drip irrigation versus sprinklers. All right, so you've probably seen these ginormous sprinklers on farms, right? Like this right here, right? They're huge. You might have seen where it's like in one central spot and it pivots around this giant circle. Okay, these are huge. They are going to use up a lot of water, and they're really not good. Okay, but all the farmers already have everything they need for them. So here we are. We're gonna tell farmers, hey, yeah, all that money you put into all that irrigation system, thanks, but get rid of it because it's not good for the environment. What the heck are the farmers gonna say? I've already spent my money. I'm not going to spend new money on a new system that you're then going to tell me isn't good and it's not going to water my plants enough. You got to understand where they're coming from. Problem is, it really isn't good. Their old system's really not good. It wastes so much water. And it's bad for them. It's bad for the environment. It's bad in every way possible. So the drip irrigation system, it's a simple, think of a hose with just a bunch of little holes in it. And it literally just drips water. So it's constantly watering the plants. Okay, because that's the other thing. They used to run these guys, all times of the day. Problem is, the only time you really want to water the plants is early in the morning. Same with your yard. Do not water the plants. Same time, that's the worst time for you to get a sunburn. It's the worst time of day to water these plants, any plants. Because the water droplets stay in the plants, right? The only part of the plant that's going to suck up the water is the roots. Yet, the entire plant gets soaked with the water, especially the leaves. And what happens when you take a magnet to a leaf? Not a magnet, sorry, a magnifying glass to a leaf. It burns the leaf, right? That's what's happening to these crops. They're getting burnt because the water droplets are staying on the plants because the leaves are not sucking up the water, only the roots do, but the entire plant is soaked. Then the sun comes up, beats down on them, those water droplets become magnifying glasses and it burns the plants. So you actually have a reduction in crops. So we have to explain to the farmers, hang on, do this drop irrigation system. Your crops are going to be better off for it. You're going to have better crops. Less water is going to get wasted. In the long run, it's going to be better for everybody. But short term, yes, they're going to have to spend money on new equipment, these drip lines. So you got to keep in mind both sides of the story, guys. Okay? All right, so water conservation in industry. In agriculture. All right, so there's drip irrigation. I made a boo-boo. Drip irrigation is supposed to go down here, you guys. I'm so sorry. Okay, so drip irrigation is an alternative. Apologies. And up here, you've got slow. Okay, I'm gonna write it here. Sorry. Slow depletion of water source to keep the price reasonable. I'm so sorry. All right, most water lost to evaporation. Evaporation. I'm sorry, I made a boo-boo. Water conservation in industry, recycling, cooling and wastewater. So the cooling water, that's the water that's used in power plants to cool down the power plant so it doesn't overheat. You recycle that water. That'd be better. Wastewater, water that's coming off of the plants as well, the recycling plants, power plants. Water conservation at home. Start taking. So what can you do? What can you do at home to conserve water? How about shutting off the water when you're brushing your teeth? Taking shorter showers? Things like that, okay? So solutions for the future. Removing salt from salt water. That's what we call desalination. I'll change colors. Ooh, let's go with gold. Okay, transport. Bringing in water from other regions. But then you're going to take water away from those regions, so that's good and bad. Two main causes of pollution. Industrialization. And human pollution. Human population, apologies. So, water pollution, introduction of chemical, physical, and biological agents into water that degrade water quality. H2O is water, remember? Water quality. And adversely affects the organisms that depend on it. So, what is a point source? Point source can often be identified and traced back to the source. Non-point solution, since the pollution comes from different places, it's hard to regulate and control. Control depends on public awareness. That's further down on your paper. So, what two kinds of sources? You've got point source pollution. Pollution discharged from one single source, factory, a leaky tanker. And then you've got non-point source pollution. It comes from many different sources. That are often hard to identify. Could be runoff from a river, from the surrounding shed, okay, and then who knows how it got there. Major types of water pollutants. Pathogens. I need you to know about a pathogen. Remember, those are disease-causing organisms, mainly from fecal matter, feces, poop. Okay, that's a non-point. Number 2, organic matter. Plant and animal matter that remains. That's a non-point. Organic chemicals, pesticides, fertilizers, plastics, detergents, petroleum products. Those are all non-point sources. Inorganic chemicals, that's your acids, your bases, your salts, industrials. Chemicals, those are point and non-point. Then you have heavy metals. Your lead, your mercury, your arsenic, point and non-point. And then you have physical agents. Heat and suspended solids, point and non-point. And we'll go back to those slides in just a minute. All right, most of the biodegradable material can be broken down by living organisms. Okay, if it's biodegradable, it can be broken down by living organisms. sewage sludge. I really like this one, this color. The solid material that remains after treatment, it can be incinerated or used for fertilizer or mixed with clay and used for bricks. There's a lot of different ways. All right, so let's go to those slides. So you've got point. You can point at it. You know the point. You know exactly where the pollution came from. Point source solution. Leaky septic tank. Leaking storage lagoons for polluted waste. Unlined landfills. Erin Brockovich story. If you've ever seen that movie, you gotta get your parents' permission to see that movie because there's a lot of bad words, but really, really, really good example of point source pollution. Leaking underground storage tanks that contain chemicals or fuels, such as gasoline that leaked out. This right here is why oh my lord, gasoline stations can talk. Gasoline stations can only be around for about 7 to 8 years, if I remember right, the exact number. Then they'll close down because their tanks that hold gasoline will start to leak. So they'll fill them up, and that's it. They'll shut it down, move on. Right here, because after a certain while, they'll start to leak, okay? Polluted water from abandoned and active mines, water discharged by industries, public and industrial wastewater treatment plants. All these are point source pollution. Then, of course, the opposite is going to be non-point sources of pollution. Chemicals added to the roads, salts and other de-icing agents. It goes from the roads to, whatchamacallit? Oh my lord. To the side of the road that gets carried out to the land, which carries out to the river, the wetlands, what I was thinking of, to the river, to the ocean, blah, 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 blah. Water runoff from the city and suburban streets that may contain oil, gasoline, animal feces, litter. Where did it come from? Which animal pooped it that got carried away by the rain? Down to the sewer system, out to the ocean. Pesticides, herbicides, fertilizer from residential lawns, golf courses. Which lawn, which golf course, which farmland was the actual cause? There's no way to find that out. Fecal matter and so poop and agricultural chemicals from livestock feedlots. I mean, we have to have livestock fed in order for us to have food in the grocery store, for us to have food at home. But which was the specific one that caused that particular increase in algal bloom, such as the red tide? There's no way to know. Precipitation containing air pollutants, soil runoff from farm and construction sites. Which construction site? Good Lord, if you try to figure out which nail put which nail went into your tire, with all the construction sites we have in Nassau County, you never figure it out, right? That's a non-point solution, non-point source of pollution. And then oil and gasoline from personal watercrafts. All right, pollutant types and sources. As we've discussed, disease causing, those are your pathogens. And then you've got all the same examples that we've talked about in the notes. I'm gonna let you guys look at that on your own time. Okay? Come back to that one when we're done. When we get to it, discard. Okay. Wastewater. Wastewater. I'm changing colors. Oh, go green. Water that contains waste from homes or industry that goes down the drain. It's treated in industrial plants, so it's safe. So it's safe enough to return to rivers and lakes. I'll go back to that slide in a minute. Things that we do to pollute, something we call artificial eutrophication. I need you to know that word. Eutrophication. Eutrophication. This right here is what led to the red tide. All right, it's where you got too many nutrients in the body of water. It's what happens in my tank. I keep getting them food. They keep pooping. They don't eat all the food I give them. All that food and all that poop mix into the tank, and it just sits there and it sits there and sits there. And if I don't keep it under control, all of a sudden I'm going to have bacteria that grows like crazy. It grows all over the side walls of the tank, right? Grows all over the rocks. That is eutrophication. EU silent, eutrophication, okay? Lethal algal blooms and suffocation of lakes. And what happens is there's not enough oxygen in the water to support all of the bacteria, because we've got this algal bloom, all the algae that just took off in numbers. There's so many of them. So the algae start to die, the fish start to die, the bigger fish start to, everything around there starts to die off. Okay? And red tide, what we had happen in South Florida, actually from Central and all the way to South Florida, we also had mammals died, we had dolphins, manatees, we had sea turtles, whale sharks, we had, you name them, they took a hit. Okay? So we're trying to keep that under control so it doesn't happen again. Thermal pollution. Believe it or not, whoopsie, having an increase in the temperature of a body of water, that's a problem. We don't want to change the temperature of the water, because remember my fish, they like the temperature they like it at. They don't like it any warmer or colder. They like it just right. Okay? Oxygen in the water drops and organisms can die from suffocation and heat. And then you've got groundwater pollution. That's a huge no-no. Because if you pollute your groundwater, you are in deep trouble, right? Groundwater pollution is hard to clean up because groundwater recharges very slowly. And because pollutants stick to the materials that make up an aquifer. If you guys don't mind, I'm going to keep going and I'll go back and do the last 3 slides, okay? Ocean pollution is the most of it comes from non-point sources on land, right? We know this. Most of the pollution found in the ocean comes from land. Pretty messed up. Garbage, waste, sewage dumping. All right. Oil spills. That's next, yes. The number 1 cause of pollution in the ocean is from land activities. Water, CWA, banned pollutant discharge, required removal of heavy metals. Clean Water Act. CWA stands for Clean Water Act. Apologies for that one. Many pollutants accumulate because they do not decompose. That is a huge problem. Then we have biomagnification. Okay. What in the heck am I talking about here? All right. So you've probably heard that you want to be careful eating too much tuna or too much of your larger fish like that, larger predatory fish. And it's because of this right here, biomagnification. And because tuna is actually quite high up on the food pyramid. So you've got the small fish that eats a lot of plankton, and then you've got the slightly larger fish that eat the small fish, and then you've got the medium fish that eat the slightly larger fish than the small fish, and then you've got the larger fish that eat the medium fish, and then you've got the bigger fish that eat the large fish, and then you've got the tuna that eats the large fish. Well, every single time, right, because the tuna at the higher up, and there's only what percent of energy goes up each trophic level? 10%? Yes, very good. 10%. So if you're at the top, you're the tuna, you need to eat a lot. You're eating stuff that's eating other stuff that's eating other stuff that's eating other stuff that have all eaten mercury. So the tuna actually has a lot of mercury accumulated.